Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So this is the unbalanced reaction that is mentioned in your screen. So as we can represent, the first step should be whether to check whether the atoms rather than oxygen and rather than hydrogen are being balanced or not. So as we can see, the number of moles of iron that is 1 in the reactant side, and the number of moles of Fe3 plus ion is also 1. So the both are balanced. Now talking about the bromine, which is again 1 mole of bromine is present on the reactant side, while the 1 mole of bromine in the form of ion is present on the right hand side, that is on the product side. So therefore it has been mentioned that the both are being balanced, both the atoms are being balanced. So now move towards the first step. In this case, it won't be the balancing the bromine or balancing the iron. It will be finding or determination of the oxidation state of the atoms. So the step number 1 would be determination of oxidation number. For the first reactant, if I would say that is for Fe2 plus, we don't have to calculate it, because as it is mentioned clearly that the number of charge present on Fe2 plus is 2, which is positive. So therefore the oxidation number of Fe2 plus is 2 plus itself. So the oxidation number of Fe, that is of iron, in Fe2 plus is 2 plus, while that of bromine we have to calculate in BrO3 minus. So for that I could write it as the oxidation number of the whole molecule, that is BrO3 minus, is 1 minus. So how can we calculate it? I'll do it in this way. So for determination of BrO3, we have Br, that is bromine, which is present 1 times, plus oxygen, which is present 3 times, and the overall charge which is present on the molecule is 1 minus. I could write it as minus 1. So therefore I consider the oxidation number of bromine as X, as we did earlier also in the determination of the oxidation number. So therefore X plus 3 into minus 2, this will give us minus 1 overall. Therefore X is equals to minus 1, minus 6 will go that side and it will become plus 6, and therefore X is equals to 5. Therefore we should write this statement when we are giving the examination of 11th. So this steps should be involved so that it could be very helpful to give you or to get you full marks. So therefore the oxidation number of bromine in, that is BrO3 minus, is plus 5 or 5 plus, while the rest of the product that I could observe in the product side is, so the rest of the oxidation number for the product side will be, as I can see, for Fe3 plus the oxidation number is 3 plus, while that of for Br minus, the oxidation number for Br in this case is 1 minus. So this has been clearly explained earlier also. So now what we are going to do is we are going to check whether the reaction is been redox reaction or not. This step should be followed by every student, because it might be that the reaction might not be a redox reaction. So it is the duty of a student, or it is for us to concern whether the reaction is oxidation and reduction taking place simultaneously, that is the redox reaction is been taken place in the reaction or not. So we'll check it first. So the overall reaction that we have now with us is Fe2 plus BrO3 minus, that should give us Fe3 plus Br minus. The oxidation number of Fe2 plus was found to be 2 plus, while that of bromine atom in BrO3 was found to be plus 5, while in case of Fe3 plus is clearly mentioned as plus 3, and while case of Br minus, it is mentioned as 1 minus. So what we are going to do is, we are going to compare this Fe2 plus with this Fe3 plus and this Br with this bromine, and let us check which process is been occurring in changing of these molecules or these ions. I could see that this 2 plus is being converting into 3 plus. The oxidation number is changing from plus 2 to plus 3. So it is only possible if electrons are being lost by the Fe2 plus ion. So because of electron are being lost, it is said to be oxidation. While in this case, as we can observe, that is the number of oxidation is 5 plus, while in this case is 1 minus. So if positive charge is being converting to a negative charge, this will only happen if the 5 plus charge will accept more number of electrons. The oxidation number is being now negative. So electrons are being gained in this process, and since electrons are being gained in this process is said to be reduction. So it has been clearly mentioned that it is now a redox reaction. So this is not over yet. We have to balance the electrons also. So how can we do that? Let us see by taking the step number 2. So the step number 2 will be balancing electrons. So electrons are being lost during oxidation. So let us see that how many number of electrons are being, or how many number of moles of electrons are being lost during oxidation. So therefore the number of electrons lost during oxidation, and we will also calculate for the number of electrons gained during reduction. So let us take it the last equation that we have balanced, or we have deduced whether the reaction is reduction or not, or whether the reaction is occurring oxidation or not. So in this process I could see that the oxidation number is changing from plus 2 to plus 3. This is possible if the number of electron lost would be 1. So therefore the number of loss during oxidation process in this case is 1. While the number of electrons or the number of moles of electron gained during reduction will be what? It is converting from 5 plus to 1 minus. So how are we going to calculate the number of electrons gained? Since it is been converting from 5 plus to 1 minus, which means if 5 plus charge has accepted 1 electron, then it will become 4 plus. Another 1 electron, 3 plus. Another 1 electron, 2 plus. Another 1 electron, 1 plus. Another 1 electron, then 0. And another electron, if it takes, then it will become minus 1. So overall it has taken 6 electrons. So therefore the number of electrons during acceptance of during reduction process in this case is now 6. So the number of electrons that has been gained during reduction is 6, while the number of electrons that have been lost during oxidation process was 1. So the electrons are not being balanced. So we can't tell or we can't deduce that this would be a redox reaction which is balanced with electrons. So what we are going to do is we are going to do a cross multiplication. As you can see, the 1 will be multiplied by 6, while the 6 will be multiplied by 1. It means the reactant species or the species that shows oxidation will be multiplied by 6, while the species that shows reduction process will be multiplied by 1, or it should not be multiplied by any number. It should be as it is. So let us balance the previous equation. So the previous equation, which was this one, in this case the oxidation number or the oxidation process should be multiplied by 6. So therefore we will multiply 6 times of Fe2 plus, and if the Fe is being repeated or is being multiplied by 6, then in product side also we have to multiply it by 6. So let us write the overall equation as, and in this case we don't have to multiply Br with any number, it should be as it is, it will be the same. So therefore the equation that we have got right now after balancing the electrons will be 6 times of Fe2 plus Br O3 minus, that should give us 6 times of Fe3 plus ion plus Br minus. So this is the equation that we have balanced with electrons. So the next step would be, balancing oxygen. So let us do it. So the step 3 will be balancing oxygen atoms. So the number of oxygen atoms on left hand side and the number of oxygen atoms on right hand side. So let us calculate it by taking the latest equation that we have balanced. So in this case, the number of oxygen molecules present on the reactant side is 3, while the number of oxygen molecules present on the right hand side is 0. So there is a deficiency of oxygen atoms on which side, or on which reactant side or product side? Yes, it has been clear by the number itself that the number of deficiency is 3 on right hand side. So therefore what we are going to do is we are going to add 3 times of H2O on the right hand side. So therefore the overall reaction that is now being written as 6 times of Fe2 plus BrO3 minus, that should give us 6 times of Fe3 plus Br minus plus 3 times that of H2O. So this is how we have balanced with the number of oxygen atoms, and now what we are going to do is we are going to balance the number of hydrogen atoms. So the next step would be, we would consider this step as the latest balanced equation and we'll keep aside, but we should consider this as the final answer till now. So the step number 4 would be step number 4 will have a name of balancing hydrogen atoms. So therefore the number of hydrogen atom on LHS and the number of hydrogen atoms on RHS or on the product side. So let us see the step number 3 where we have calculated So in step number 3, we have got to know that there is no hydrogen present on the left hand side. So the number of hydrogen atom on left hand side is 0, while the number of hydrogen present on the right hand side, and in this case we are talking about hydrogen atoms, is 6. So I could write it as, on left hand side it is 0 and on right hand side it is 6. So what is the deficiency and where? There are 6 hydrogen atoms which are deficient on the left hand side. So what we are going to do, we are going to add 6 times of H plus. So therefore adding 6 times H plus on left hand side, or on the reactant side, or on the deficient side. Therefore the overall answer that I could get is 6 times of Fe2 plus plus BrO3 minus plus 6 times of H plus. That should give us 6 times of Fe3 plus plus Br minus plus 3 times of H2. So this is the equation that we have got after balancing in acidic medium. So it was very much simple and not too much tedious like the last previous two one. So I hope you have got it, and you have got an idea how to solve this kind of balanced equations, unbalanced equation to balanced equation. So thank you friends for watching this video. I hope you have liked this video, and share this video with your friends and let them know too. And yes, don't forget to subscribe Ekeeda channel. Thank you so much.